Let us see how we can execute a subprogram defined in the package specification which has been implemented in the body. Of course, you cannot call subprograms private to a package body from outside, but you can only call the subprograms which have been defined in the specification. Here in this code snippet, we have declared LEMP-ID and given it a value of 50. LDPT name is with an initial value of IT. Inside the execution section, we call the procedure as demo.hrmanagement.updateEMP, passing in these two parameters. Here, demo is the schema name and is optional, and since we are running it from the demo schema itself, we could have actually omitted it. Let's run this. We see the result, updated rows 1. So calling a packaged procedure is similar to a standalone procedure, except that you have to prefix the package name. Now let me demonstrate to you stateful and stateless packages. The way the packages are defined now, they are stateful since we have a few constants and cursors at the package level, as well as g_% which is a global variable which can hold the session data and hence session state. In the demo session, let's first grant execute on HR management to test to allow test to execute this package. I've got another session over here logged in as user test. Here is the same anonymous block we just ran. Let's try and run it again. We get the same result, update rows equal to 1 as we expected. Now let us go back to our demo schema. Over here, let us compile the package using alter package HR management compile. The package got altered successfully, and since this is a stateful package, Oracle would have discarded the state of this package in other sessions. Let's go back to our test session and let's try and run this anonymous block again. We see a message Aura 04068 existing state of packages has been discarded since HR management is a stateful package and Oracle, to keep everything accurate, discards the existing stage upon recompilation. This would be true if we would have compiled just the body or the specification. Let us see how we can make our package stateless. We are back in our demo session. We have created a package specification global state where we have taken out all the constants, the global variable g_%, the cursors declared at the package specification and the body level from the HR management package. Let's compile this. So here is our stripped down package specification for HR management. All it has now is the global exception, the type definition, and the subprogram definitions. Let's compile this. And here is the package body for HR management. Notice we have removed the cursor from the top, and all references to the global variable, constants, and cursors have been prefixed with the global state prefix. Now let us compile it again. I started a new test session, and now let us run the anonymous block again. It comes back with the expected result. Let's go back to our demo session, and let's compile this package over here again. We can compile the specification or body or both. Since we have removed all the constants, variables, and cursors, it's a stateless package. Let's go back to our test session and let's try and run the anonymous block again. It runs just fine and the package state is not discarded. This demonstrates one way of keeping your package states from being discarded by separating the constants, variables, and cursors in a separate package of its own, and thus making our package a stateless package. Using the statement drop package body HR management, you can drop just the package body. Using drop package HR management, you can drop both the specification and the body in one go.